Okay, here is the take-home problem about the projectile motion with air resistance. And here's the picture that we're looking at. I want to get you going on this problem because it's tough. I've been working on it, and I thought if I got you going, though, you'll be fine. Uh, First of all, I want to look at this velocity. This is essentially a vector. It has two components. It has a horizontal component here, and it has a vertical component here. And you can treat these just like triangles. And here's theta. And if I call this side, if I want to find this side right here, I know that the cosine of that side, I know cosine of theta is going to equal, let's call that side 1, S1 over V. So S1 equals V cosine theta. So that is, right here, this blue is V cosine theta. So that is my velocity in the x direction. That is dx dt. And dy dt is going to be given by this side. And in a similar way, you can get that is V times sine theta. Okay. Now I want to look at this drag. What are they calling in the book? The air resistance retarding force K, and so it's a multiple velocity, so that's why I called it CV. So this thing has two components as well. It has the vertical component here and has the horizontal component there. And I'll leave it up to you to check that these angles are indeed the same. That is, if that's theta, that's the same thing. And it's all because this force is acting directly opposite of the velocity. Parallel lines intersected with a transversal, you can get it. In a similar way, we'll get that this side here is going to be CV cosine theta, and the force acting in the y direction is CV sine theta. So now let me go in green here and set up the differential equation. I'm going to get in the x direction, let's see, number 1, we've got force is mass times acceleration, md squared x dt equals, and the only force acting in the x direction is going to be this force acting against it there. That's going to be a negative CV cosine theta. Okay. Now number 2, we've got mass times acceleration in the y direction. Oops, I should have put a square there. Over dt squared is going to equal, let's see what's acting. We've got gravity pulling down, negative mg, and then we've got the drag force there, minus CV sine theta. And that's going to be our differential equation that we have to solve. One thing, let's see, what I don't, looking at it right now, what I don't like is we have the thetas in there. I'd rather figure out how to figure out a way to write cosine theta and sine theta in terms of t.